Something changed at Yellowstone. New vents open near Black Diamond Pool. Horrible in Venezuela. Twin massive earthquakes trigger a state of emergency. Caracas left in ruins. The ground at Yellowstone National Park has changed once again. In one of the park's most active geothermal regions, scientists have documented the sudden appearance of several new hydrothermal vents near the infamous Black Diamond Pool in Biscuit Basin. The discovery follows a small hydrothermal explosion that occurred before dawn on June 13, 2026, reminding researchers that Yellowstone's thermal landscape can transform in a matter of minutes. At approximately 5:09 a.m. local time, monitoring instruments detected an unusual combination of seismic vibrations and low-frequency acoustic waves known as infrasound. These signals originated from the vicinity of Black Diamond Pool, the same area that produced the dramatic hydrothermal explosion witnessed by visitors in July 2024. However, this time, scientists quickly realized that the famous pool itself was not the source of the disturbance. Instead, something entirely new had happened beneath the surface. As daylight spread across Biscuit Basin, park staff noticed an unusual gray, milky plume flowing down the Firehole River. The discoloration stretched for several kilometers, suggesting that large amounts of hot water and fine sediment had suddenly entered the river system. This observation prompted geologists to investigate the surrounding thermal area in detail. What they found was remarkable. North of Black Diamond Pool, the landscape had been torn open by 3 newly formed vent systems. Long fractures had appeared where solid ground had existed only hours earlier. One fissure measured roughly 18.5 meters, or about 61 feet, in length and reached up to 1.5 meters wide in places. Another vent extended nearly 15 meters to the northeast, while several smaller openings formed between them, near boiling water measuring between 185 degrees and 200 degrees, 85-93 degrees, continued flowing through these fractures, releasing clouds of steam into the air. Unlike a volcanic eruption driven by rising magma, this event was a hydrothermal explosion. Hydrothermal explosions occur when underground water trapped beneath layers of rock suddenly loses pressure. Water that had been heated beyond its normal boiling point instantly flashes into steam, expanding violently and blasting apart the surrounding rock. These explosions are extremely powerful on a local scale, but they do not indicate that Yellowstone's supervolcano is preparing for a major eruption. Scientists emphasize that the event reflects shallow, geothermal processes rather than movement of magma toward the surface. Perhaps the biggest surprise came several days later. When geologists returned to the site, they discovered that the ground they had walked across only 2 days earlier had collapsed into a brand new thermal pool measuring approximately 21 by 17 feet. Filled with vigorously boiling gray, sediment-rich water, the newly formed pool appeared almost overnight, Researchers believe the feature developed through gradual collapse rather than another explosion because no fresh debris surrounded its edges. The new pool soon became even more active. Camera observations recorded intermittent bursts of water shooting 20 to 30 feet into the air, giving the pool a temporary geyser-like behavior. Between these episodes, the surface continued to churn violently as steam bubbles formed and collapsed beneath the boiling water. Scientists are still unsure whether this feature will eventually stabilize into a permanent hot spring, evolve into a true geyser, or slowly become inactive over time. Fortunately, no visitors were injured. Biscuit Basin has remained closed since the much larger hydrothermal explosion in 2024, a decision that likely prevented injuries during this latest event. Hydrothermal explosions are notoriously difficult to predict because they often occur with little warning, making closed areas around unstable thermal features especially important for public safety. For scientists, however, this event represents an extraordinary research opportunity. The explosion occurred only about 100 meters from a monitoring station installed in 2025, making it one of the closest hydrothermal explosions ever recorded by modern instruments at Yellowstone. Researchers have since installed additional temporary seismic stations around the new vents, hoping to identify subtle warning signals that could improve understanding of these unpredictable geothermal events. While the emergence of new vents may appear dramatic, experts stress that this is part of Yellowstone's constantly evolving hydrothermal system. The park's vast underground network of hot water, steam, and fractured rock continually reshapes the landscape, creating new pools, closing old ones, and occasionally producing powerful steam-driven explosions. The opening of these new vents near Black Diamond Pool is yet another reminder that Yellowstone is not a static landscape. It is a living geothermal system, one that continues to change, sometimes overnight, revealing the immense natural forces operating just beneath the surface. On the evening of June 24, 2026, Venezuela was struck by one of the most destructive seismic disasters in its modern history. Within just 39 seconds, two powerful earthquakes measuring magnitude 7.2 and magnitude 7.5 tore through the country's northern region, unleashing violent shaking that devastated communities from the Caribbean coast to the capital, Caracas. Authorities quickly declared a nationwide state of emergency as rescue. Teams raced against time to search for survivors, trapped beneath collapsed buildings. The first earthquake struck as what scientists now describe as a foreshock, rupturing part of a complex fault system between the Caribbean and South American tectonic plates. Before emergency services could even assess the initial damage, the larger M7.5 main shock struck less than a minute later. This rare phenomenon, known as a seismic doublet, dramatically increased the destructive power of the event, causing structures already weakened by the first shock to collapse completely during the second. Residents in Caracas described the terrifying moments as the ground rolled beneath them. Apartment towers swayed violently, windows shattered, and clouds of dust filled the streets as sections of buildings crumbled. Electricity failed across parts of the capital, communications were disrupted, and frightened families poured into open spaces fearing more collapses. Many spent the night outdoors as powerful aftershocks continued to shake the region. Some of the worst destruction occurred in neighborhoods where multi-story residential buildings suffered catastrophic structural failures. Rescue workers, firefighters, soldiers, and volunteers worked through the night using heavy machinery, search dogs, and even their bare hands to reach people trapped beneath concrete and twisted steel. Every hour that passed became increasingly critical as hopes of finding survivors slowly diminished. The coastal state of La Guaira, located just north of Caracas, experienced even more severe devastation. Numerous buildings collapsed, transportation infrastructure sustained major damage, and the region's international airport was forced to suspend operations, complicating the arrival of emergency assistance. Roads were blocked by landslides and debris, making it difficult for rescue crews to reach isolated communities. Hospitals rapidly became overwhelmed as hundreds of injured residents arrived within hours. Schools, sports facilities, and public buildings were converted into temporary shelters for families who had lost their homes. Medical teams worked continuously to treat fractures, crush injuries, and trauma, while emergency officials coordinated food, water, and medical supplies for thousands of displaced residents. Government officials declared a national state of emergency and mobilized military units to assist rescue operations, secure damaged areas, and distribute humanitarian aid. International rescue teams and emergency assistance soon began arriving from several countries, bringing specialized urban search and rescue equipment, medical personnel, and relief supplies to support Venezuela's overwhelmed emergency response. According to seismologists, northern Venezuela lies along the active boundary between the Caribbean Plate and the South American Plate, where accumulated tectonic stress is periodically released through powerful strike-slip earthquakes. While earthquakes of this size are uncommon, the occurrence of two major ruptures only seconds apart is exceptionally rare, greatly amplifying the damage because buildings weakened by the first quake often cannot withstand the second.